So now let's look at this slightly longer problem. The problem might look long, but it is actually very simple, and such problems can be asked in the exam where the actual maths is very simple, but the problem is long. The comprehension, the amount of reading that you have to do is actually a little bit more. So here there are two machines, the machine A and machine B, and they are producing a batch of computer parts. This batch of computer parts, this entire batch, we will just say that this is 1 unit of our work. We are not concerned about what this batch contains, maybe it's 30-40 parts. We don't go inside this batch, but we just say that this is just 1 unit of work. So we'll say that the machine A takes 3 hours to complete 1 unit of work, but that is not the case. Okay, unfortunately what has happened is that after I bought the machine, I realized that for every 10 minutes of work that the machine does, it takes 1 minute of repairs, which essentially means that 10 minutes of work is being done in actually 11 minutes. Okay, which means that 1 minute of work is being done in 11 by 10 minutes. So this is our unitary method, and that would mean that this 3 hours of work is actually being done in 11 by 10. So there is no minute here. Okay, this minute and minute actually cancel, so there is no dimension here. This is just a ratio or a fraction. So 3 hours of work is being done in 11 by 10 into 3, which is equal to 33 by 10 hours. Okay, so instead of taking that 3 hours, the 1 unit of work is being done in 33 by 10 hours. The same thing is happening with machine B. I have been very unfortunate. So what has happened with machine B also, that for every 3 minutes, okay, so every 30 minutes of work, the machine becomes overheated, something happens. So I have to give it a break for 3 minutes. So again, we'll do the same thing. So what has happened for machine B, that this 30 minutes of work requires 33 minutes, 30 plus 3, 33. So this gets cancelled on both the sides. What we can do is we can cancel it right here. So this is again 11 and 10. Okay, so this is 10. We can cancel both the sides by 3. Okay, so for every 10 minutes of work, I really need 11 minutes. So 1 minute of work is being done in 11 by 10, and therefore this 2 hours of work is actually being done. I have to multiply with this fraction, so that is equal to 22 by 10 hours. So 2 hours is not really 2 hours, but it is 22 by 10 hours. So when the machines, they are working together, obviously they will produce the parts faster. Okay, but what about the rate of work? So 1 unit of work is being done in 22 by 10 hours and 33 by 10 hours, which means the rate of work is actually reciprocal of this, which is 10 by 22. This is for machine A, and for machine B, it is the reciprocal of this, which is 10 by 33. Amount of work, units of work is being done in 1 hour. Okay, so now I can, like we always do, we can add these two rates. We cannot add anything else, but only the rates we can add. So when they are working together, their combined rate would be in 1 hour, they would together produce, or they would together complete this much of work. And what is this? If you add these together, you will find out that this becomes, at the bottom 66 would be our common LCM, and at the top the answer would be 20 plus 30, which is equal to 50. So this is their combined rate of work. Okay, so and what is the units here? If you want 50 by 66 unit of work is being done per hour. So again, this is the rate combined. Okay, now combined rate is this much. So what about, can we now simply find out how much time would it take for them to complete the work? I can just invert this rate. Okay, I can just take the reciprocal, and the reciprocal would come out to be 66 by 50, and that is my final answer. So 66 by 50 hours. So in 66 by 50 hours, that entire batch of parts would be produced. That is our 1 unit of work when the two machines are